Hello everybody, this is Gus from Relaycorp. I'm going to be doing a technical walkthrough of Vera, which is an offline authentication system based on domain names. And I'm going to be doing this walkthrough using a working prototype of Vera. Now, first of all, the problem we are trying to solve here is that we can't easily authenticate content offline. So if you're on the internet and you're using your web browser, you can at least check the address bar and make sure that the domain name matches the one you expect. But if you're using an offline communication technology like a Walla, you need to make sure that you're actually communicating with the person you think you're talking to. And similarly, if you're reading an article that you think came from the BBC, you need to be able to be certain that it actually came from the BBC. So one option could be to compare fingerprints, like the fingerprint of a public key or maybe the actual data. But the problem with this approach is that it's unintuitive, it's error prone, it's really hard to distribute fingerprints securely, and non-tech savvy users simply won't do it. And obviously, technically an alternative could be to use PGP, but obviously it offers some really bad usability, and it's still very hard to distribute keys securely before you can even start the communication. So, but if you think about it, your bank will never ask you to check their TLS certificate, not by comparing fingerprints and certainly not by storing the certificate up front before any communication can begin. So we know that this problem is already solved by asking users to check the domain name in the address bar in this case. So we should be able to use a similar mechanism to offer authentication offline. And that's precisely what Vera does. So Vera uses DNS to provide offline authentication. So let's consider two examples here. So on the left-hand side, we have, in this case, HTML that has been produced by the BBC. And we can tell that it was produced by the BBC because along with this HTML, there will be a Vera signature that proves that that's the case. So if I were to distribute this piece of HTML offline along with the signature, then a compatible app can open it and tell the user this definitely came from the BBC. So for example, if they open it in Firefox and Firefox supports Vera, then the user will be able to see that the web page came from the bbc.com website. And if we consider a different example, so for example, on the right-hand side, we have a piece of XML that was produced by a decentralized messaging app. More precisely, it was produced by a user called, in this case, Tyrion@lannister.com. And what he's trying to do is he's trying to communicate with Daenerys@Targaryen.com. So Tyrion's app generated this XML file that is then going to be sent to Daenerys in such a way that Daenerys can be certain that it came from Tyrion. One thing that you need to that you will notice is that there is no user intervention whatsoever. So as a user consuming this data, I don't need to do anything up front. Absolutely nothing. No download of any public keys or anything like that. Literally no user intervention at all. And in this example, we are using XML and HTML, but it can be anything. It could be a video, a PDF, a software installer. It doesn't matter what it is. The reason why this works is that Vera Signatures embeds everything needed for the verification. So it includes the actual digital signature of the content we want to authenticate. It includes the Vera certificate for the signer, and the signer can be bbc.com or it could be Tyrion@lannister.com. It includes the Vera certificate for the organization, and organization in the context of Vera is the domain name. Not to be confused with a TLS certificate for a given domain name. There are no TLS certificates involved here whatsoever. Vera doesn't know anything about TLS. It doesn't need to. And lastly, and most importantly, it includes the full DNS-sec chain for the TXT record containing the organization's public key digest. And this is how we are going to be certain that the Vera certificate for the organization is authentic, because it matches the one we set on the DNS for the domain name. So this all means that any app verifying signatures, all they need to have, apart from the actual signature, is a copy of the root DNS-sec key digest, which is published by IANA. So that means that there are no external queries here, no DNS lookups. It's not necessary. So that's it. Let's now see Vera in action. Right, so we are going to be using the domain name chores.fans. So a community of people who like chores, because who doesn't? So as an organization admin, the first thing I need to do is check that that my domain name has DNSSEC properly configured. So I'm using this tool by VeriSign, which shows that everything is fine, so I can move on. So now this is my DNS hosting provider, Cloudflare in this case, and I haven't got any records. That's fine. We're going to create one in a moment. So I've set up a few terminal windows so that we can see what the different actors will be doing. Obviously, this is just a prototype. There will be no CLI to be used by any user of Vera. In fact, they don't even need to see the word Vera anywhere. So we've got a tab for the organization admin. So organization admin is basically anyone that manages the DNS for Vera, the DNS for the organization, and therefore Vera. And then we have the organization member, who's anyone that generates Vera signatures. It could be on behalf of the organization, or it could be on behalf of a member of that organization. And then we have the signature consumer, which is basically anyone that sees something like this data came from chores.fans or gus@chores.fans. So with that in mind, as an organization admin, I need to provision Vera, because we haven't done that before. So the first thing we need to do is we need to generate a private key, which we are going to save to that path, and we're going to generate the key for this domain. The domain is only used to produce this nice output of the TXT record we need to compute. It has nothing to do with the generation of the private key. I'm being told that I need to create this TXT record and set it to that value. So I'll go back to Cloudflare, add record, txt underscore vera.chores.fans, and this is the value we copied. So basically this is saying the public key in the root certificate is of this type, and the SHA-256 digest of the public key is this. And lastly, this is the time to live, TTL, of not just the Vera TXT record, but the whole DNS-sec chain that when we verify the signature. And this is very important to set because even though DNS doesn't quite restrict the TTL, some providers like Cloudflare do cap it at 1 day. So we're going to need a lot more than a day. So by default, the tool we are using is setting the TTL to 90 days. If you want, you can tweak that. The protocol in the end, like the final protocol, is going to have a cap just in case you make a mistake. So we save that record. And so now Vera is basically ready to be used, so the DNS is properly configured. So now let's say that as an organization member, I want to start signing things with my Vera ID. So I'm going to generate, the first thing I need to do, or my app needs to do, is it needs to generate a private key. So I'll save it at that path. That's it. So now that I have that key, the next thing to do will be to export the public key, because this public key is the one that I need to send to my organization admin. And by the way, one thing that I should have mentioned before is that obviously here we're using the CLI, it's a prototype. In the real world, this is probably going to be just a nice web page where you can just, as an admin, you can just copy and paste that and paste it in your DNS hosting provider's website. Similarly, as a member, you're not going to see any of the ugly low-level stuff that's going on here. You're just going to get some mechanism to export the public key. You may not even need to see the public key, because we could be using, if you have access to the internet, things will be easier. So for example, you could use Google authentication or email authentication to send the public key to your provider and have the Vera ID automatically issued for you. So but here we're going to be doing things by hand, just so that you can see what's going on behind the scenes. So as an organization member, now I have a public key that I need to send to my organization admin, and let's assume that I just sent it. Now the admin, let's also assume that the admin did some authentication on you before giving you a Vera ID. So once that's done, then because the Vera ID will include a few things that we haven't yet retrieved, we need to retrieve them now. So that we haven't yet retrieved the DNS-sec chain, so we need to do that now as an admin. I mean, this is public, so it doesn't matter who does it, but in this case it has to be the admin. So this file right here, it contains the whole DNS-sec chain from this TXT record all the way to the root of the root zone. Now we don't need to do it before generating every certificate, but it's you can cache it. But it's a good idea to give users a recent one, because this is going to expire eventually. And another thing we haven't done yet and need to do is to generate the root certificate for the domain or the organization. So we are going to take in the private key that we produced earlier, and we're going to use it to generate the certificate, which is going to be for this domain, chores.fans. So that's it. And just like the DNS-sec chain, you don't have to do this every single time you generate a certificate, but you do need to, a certificate for the member, but you do need to give the member a recent one, because it's going to expire anyway at some point. So you want to give them something recent. So by the way, this is being generated with a 90-day TTL, but you can override it. In this case, we're going to stick to the default. So now that we have the DNS-sec chain and the root certificate for the organization, we are going to issue an ID for that member that's requesting it. So we are going to take in the DNS-sec chain that we downloaded, the private key we generated earlier, the certificate that we generated earlier for the organization. We are going to restrict this member ID to this particular service, and this sequence of numbers, they denote an object identifier for the service where this ID is valid. So let's pretend that in this case the service is the web. It could be anything that you want it to be, but it has to match whatever signature you produce. We're also going to take in the member's public ID, this one, and we're going to, at the end of this process, we're going to output just one file, which is the member ID. So that contains the member certificate along with all the other things that we compiled earlier, like the certificate and the DNS chain. So this file contains all of that, and we can see that it's a relatively big file. So it has 4.7 kilobytes, but it's probably not too bad. So now that we have the member ID and we've given it to the organization member, then that member can start to use it to sign stuff. And you'll notice that we didn't pass a username when we issued the ID. So that means that we generated this ID for a bot, and a bot in Vera acts on behalf of the whole organization in the context of this service, of course. But there is no username because the member is acting on behalf of the organization. So as a member, we can now start generating signatures. So we are going to use this tool from the prototype to sign. Let me show you first of all what we're going to sign. So we're going to sign this article, which we are going to pretend is a nice HTML file with some CSS and images. So we're going to sign this now. So this is going to take in the member's private key, the member's ID, the file we want to sign, so in this case article.txt, and it's going to output signature.there. So it's just going to be the signature, it doesn't embed the article. So we can see at this point we have everything we need to distribute whatever we want to distribute offline. So we only need to distribute two things: article.txt and signature.there. Now it's up to you as a developer if you want to bundle those two things together. In this prototype we are outputting the two things separately. You will notice that now signature is going to be even bigger than the member ID because it contains the member ID plus the signature. So let's see how big it is. So 5.4K. So we're going to distribute now. We are going to pretend that we have already distributed article.txt and signature.there, and that someone is going to consume this now using a Vera compatible app. So as the signature consumer, all they need to do is open the app and just see what it says, whether the signature is actually valid. So that app is going to take the signature that we produced earlier. It's going to take the service ID, which has to match the one that the organization admin used, and the actual article that we want to verify. And as we can see, the signature is indeed valid. It was signed by chores.fans, so the organization, and it's valid in the context of this service only. If you happen to have an application that is more time sensitive, so you don't need to have things that are valid for 90 days or even days, you have the option as a developer to restrict the maximum TTL for the signature. So if you want to only be valid for 2 seconds, you can enforce that, and in that case your app is going to refuse the signature as because the member ID is too old. But we're not, so in this example we don't care about that. So now let's try a slightly different scenario. Now let's assume that the admin is actually going to generate a member ID for a user, not a bot. So we are going to set a username here, in this case Gus. So we have to sign this again, but with the new ID. So I do that as a member now, specifically a user. And now we redistribute the plain text and the signature, and we can see that it was actually signed by a user, a member of the chores.fans organization, and all the other stuff I mentioned earlier still applies. So this is the service. You can restrict the TTL if you want to. So that should give you like a high-level overview of how everything works. One thing that is worth reinstating is that obviously this is a proof of concept, very rough prototype, so you can see things working, but not necessarily with the UX that you want to have in the final version of Vera or any app compatible with Vera. So just bear that in mind. So just to recap, in the real world, the organization admin is probably going to have a web interface where they can do this, and more importantly, where they can automate certain things like issuing member IDs. You don't need somebody to manually approve these things. You can do authentication based on Google authentication or OAuth or whatever you want to use, or even email authentication if you want to. From the point of view of the organization member, you obviously don't need to do any of these low-level operations that we did. The app should be able to very nicely wrap all of this behind the scenes And most importantly, the consumer, they don't need to do anything up front, and certainly they don't need to use any CLI of any kind. All they need to do is open whatever file they received and let the app tell them who produced it. So in this case, Gus at Chores Fans. So that's basically it. I'm going to leave some links in the description, so make sure to check those out if you're interested. And that's it. Thank you very much for watching.